Okay, good afternoon, class. Today we will discuss. Last time we stopped in, that after we discussed about how liquid changes to gas, how solid changes to liquid, right? The intermolecules, what happens when it vibrates and everything. I've already taught you what happened, right, during last class. So today we will study a new topic, that is evaporation. Okay, evaporation. All right. So here, first, before discussing the definition of evaporation, we will first see. Okay, so when we've seen in last class that a liquid state changes into vapor state via heating, right? So I took a beaker, I poured some water, right? I kept a Bunsen burner flame, right? And I put a lid. That's how the liquid boils, right? When the Bunsen burner is burnt, okay, and the water vapor boils, and after boiling it goes up to the lid, and the lid, it turns into vapor, goes up to the lid and forms water droplets, right? So however, in evaporation we will discuss about, do we always need heat energy to change a liquid state into a vapor state? Okay, we will discuss about what is evaporation. Okay, so here there are some stages. Okay, so sometimes heat energy is not required to change liquid state into vapor state, like I did last class, that we always have to switch on the Bunsen burner, apply some heat, and then only liquid state changes to gas, right? However, there are some examples in which liquid changes into vapor state without heating. Okay, we will see what are these examples. So suppose, what happens when you keep water, right? You keep water in a petri dish, right? In a saucer kind of thing, you pour water. Okay, in the morning you go and keep it in the sunlight. Okay, you leave it for a few hours. When you return back, what will you see? Okay, what will you see? Again, another example, when you dry your clothes. Okay, that is a very good example. Your clothes are wet, right? But when you go outside, you dry it in the sun, what happens? So that, my students, is evaporation. You did not apply any heat. You did not switch on any Bunsen flame. You did not even boil any liquid for liquid to change to gas. So here, as I told you, the examples, right? As I told you, the examples in which the examples that I already told you, that water in that saucer, it evaporates. That is the term, it evaporates, right? The water in that saucer, right, which I told you to keep outside in the sun. Okay, this water will evaporate. This water will evaporate. Okay, it will go up, all right, changing this liquid, right, into vapor. The liquid which is here will disappear, right? That is what you will see. The liquid which is in the saucer, it will disappear. It will change to vapor. You understand? So that, my students, is evaporation. All right. So you see the basic definition of evaporation: the phenomenon of change of a liquid into its vapor at any temperature below its boiling point. Why are you saying here below its boiling point? Because you are not boiling it. You understand? You're not boiling the liquid, right? You're just simply keeping it in the sun. So that temperature is not as huge as the boiling point. So it is below the boiling point. And without any external source of heat. You didn't apply any Bunsen flame, right? So without any external source of heat. Okay, it's called evaporation. You underline that line. It's called evaporation. Okay. So next, so now that you've discussed what is evaporation, okay, we will see explanation of evaporation based on molecular theory. We already discussed what is molecular theory, right? We already discussed what is molecular theory. Please turn your pages and see if you do not know what is molecular theory. Okay, I'm not going to repeat. Alright, so here, according to the molecular theory, the liquid molecules look like this. Forget about these kinetic energies for now. Look at these liquid molecules. They are far apart from each other, right? Not as far as gases, but not as close as solids, but just far apart from each other, right? Why are these liquid molecules like this? Why these liquid molecules remain liquid because of two forces. That is the intermolecular force. What is intermolecular force? Suppose this is one molecule and second molecule right here. They exhibit a force against each other, right? They have a force, okay, that pulls each other, all right? But due to the intermolecular force, the liquid remains liquid, okay? And the pressure due to air. In the liquid, in this air present, right? However, it remains liquid because of two things, that is intermolecular forces and pressure due to air. All right. Now, how does this liquid, okay, how does evaporation takes place? Evaporation is a change from liquid to gaseous state or vapor state without boiling the liquid or without giving any external temperature or external heat. Okay, so when liquid changes to gases, what happens? The molecules which are in liquids will be turned to gases. Okay, that is, which are close here, they will be far apart here. You understand? Okay, so how does this happen? I already explained this last class. When last class, when boiling, when the heat was applied, the molecules started vibrating. But here no heat is applied. However, here the molecules start vibrating on its own because the energy is coming from the sun. Okay, they start vibrating on its own. And after they vibrate on its own, what happened? They do not... See, let me tell you that molecules have different kinetic energies. Okay? Suppose I am a molecule and you are a molecule. I will have different energy, you will have different energy. It's like that. So these molecules have different types of energies. All right, after they have different type of energies and after they are vibrating, what happened? These molecules collide with each other. Okay, suppose this molecule will collide with this molecule. Okay, it will be like this. Okay, they will collide together, and after collision, this molecule, my right hand, which is a molecule which has kinetic energy 1, and my other hand which has kinetic energy 2. Okay, this molecule will give its kinetic energy to this, and this molecule will give its kinetic energy to this. They will exchange the kinetic energies. You understand? When the two molecules collide, no kinetic energies are being lost, but they are transferred from one to the other. All right. Now this collision of molecules, okay, this collision of molecules where kinetic energies are transformed from one to the other is known as elastic collision. Very important, it is known as elastic collision. Now due to this collision, okay, the molecules become more energetic. All right, so the molecule which simply had kinetic energy 1, okay, is now also getting, after collision, right, after collision with kinetic energy 2 molecule, is also getting another type of kinetic energy, that is kinetic energy 2. Now this molecule has two type of energies now. So when a person has two type of energies, what will happen? He will become more energized, right? Simply this molecule also is more energized than the previous molecule. So because these molecules are becoming more energized now, so they overcome these two forces. Do you see? These two forces holds the liquid state in the liquid state. They make the liquid state in the liquid state. But because they have more energies now, they overcome these two forces. Understand? They overcame these two forces and they move on to the next phase. Okay, so from liquid it changes to vapor state. Okay, because of collision. Okay, why does it change? Because of collision, and because of collision the kinetic energies gets transformed from from one molecule to the other, and due to this molecular collision, they have more energies. Okay, all right. However, on the other hand, okay, see this, it gave this molecule its energy, so this molecule now becomes very energized, right? This molecule will now change from liquid to gases, right? However, this energy, it has no energy anymore, or very less energy. You see, because it gave its energy to this one. This one is so energized right now that it changed from liquid to gas. What happened to this molecule? This molecule which does not have energy anymore, which is low in energy. Now, some energetic molecule leave and become vapor, whereas some of that left behind are very weak or less energetic. So because the kinetic energy here is, kinetic energy goes down, and as you know, as per the rule, as per I already discussed, when the kinetic energy goes down, the temperature also will go right? So when this happened, what happened? The temperature will cool down. Okay, so because of the kinetic energy is going low, the temperature will go low and cause coolness, right? If the temperature goes up, then it's hot, but if it goes down, it causes cooling. Therefore, evaporation also causes cooling. You understand? So this term is known as cooling. Okay, this whole term here. When energetic molecules leave and become vapor, whereas some that are left behind are very weak, right? And kinetic energies also are very less. Therefore, the temperature goes down, causing cooling. Therefore, evaporation also causes cooling. Okay. So I hope so you're clear with that concept. Now we will see the factors affecting evaporation. Alright. So the first factor is increased in exposed surface area of liquid. What do you mean by the term surface area? Surface area is this one. See, this is a circle, right? And this is a big circle. So if I ask you which one has bigger surface area, obviously you will say this one, right? This one has a big surface area. The surface area is measured by this, which is inside, okay? How big the inside is, okay? So this surface area will have more, right? So increase in surface area causes more evaporation. See, we'll take a simple example of this. If you take water in a test tube, right? Normal water in a test tube and water in a china dish, okay, and you place it outside of your window in the sun. You place it for a few hours. Then what do you think will evaporate first? What do you think will evaporate, or this water will disappear first, from here or from here? Obviously from here, right? Because this has a more surface area. Do you see the space here? It has more surface area than this test tube. This test tube, nothing will happen to it. The water will remain the same because the surface area is very less. You understand? This proves that more surface area is equal to more evaporation. Okay, so the best example of this is hot tea. Suppose you're drinking tea every day, right? You're drinking tea, but the tea is too hot. What do? We pour the tea in a saucer, right? So what happens when we pour the tea in a saucer? The surface area becomes huge. So the liquid becomes, less hot. Okay, so that is the example. I want you guys to read the examples on your own. Okay, I am just discussing one example here, but read the examples on your own. This number one is increased in exposed surface area of liquid. So more surface area equal to more liquid. Okay, we move on to number two. Number two is increased in temperature of a liquid. Okay, so if we increase the temperature of the liquid, okay, what happens? So suppose, again, we'll take an example. Take two china dishes, right? In one, you fill with normal water, right? Not hot, not cold, normal water, all right? And the other, you fill with boiling water. After you fill these two, okay, this with boiling water, this with normal water, you place it in the sun, okay? Now tell me which one will evaporate. The one that will evaporate first is this one, which has boiling water. You understand? Which has boiling water. Why? Because increasing in higher temperature means more evaporation. Okay, the more the temperature, the more the hotness, the more will the evaporation takes place. Okay, so this water will disappear first as compared to this one. Okay, example of that is feeling more cool after a hot water bath. See, if we take bath with cold water, we feel more hotter than when we take it with hot water afterwards. Okay, we feel colder, right? We could feel colder with hot water than with cold water. Okay, number three is increase in temperature of the surrounding. Surrounding means, what do you mean by surrounding? Is anything that surrounds us. Okay, so increase in the temperature of the surrounding. First, you take two china dishes, as again the same. You fill these two with cold water, same cold water. Okay, but one you keep under the shade. Okay, you know what is shade, right? Like under tree, there was no sun, so shade. And the other you keep in daylight, in the sun. So what do you think will evaporate first? Obviously, this one which is out of in front of the sun. This one is in the shade, so nothing will happen. No evaporation here. However, this one, it will have evaporation and the water will disappear. Okay, this proves that higher the temperature of the surrounding, right, higher will be the evaporation. Okay, example of this one is drying clothes in summer than winter. Obviously, when you dry your clothes in summer, what will happen? They will dry first as compared to winter, right? Because when it is summer, the temperature is higher, so more evaporation of the clothes, and clothes will dry fast. However, in winter, there will be lesser temperature and lesser evaporation. Okay, next we will discuss about decrease in humidity. So here we will discuss about what is humidity. Humidity is the water vapor present in the air. How do you know that a place is humid? Okay, so every one of you have gone to Guwahati, right? Okay, as compared to Shillong, what place do you think is more humid, Guwahati or Shillong? Obviously, it's Guwahati, because Guwahati has more water molecules present in the air. Okay, if you sit in the sun, if you go and walk in Guwahati, you will feel your face is sticking. Why? Because in that air they have a lot of water molecules, that is, it is humid. Okay, so Guwahati is more humid than Shillong. So I hope so you got the meaning of humidity. Humidity simply means more water vapor present in the air. Okay, so if you decrease the humidity, less vapor in the air, more evaporation. Okay, so if there is less water, then obviously more evaporation will takes place. Okay, this is simple, just like that. All right, the examples you look on your own. So the increase in wind speed. Okay, the increase in wind speed. Now again, here you take two china dishes, you put water in both, right? One you put under a fan. I'm sorry about my fan. Okay, okay, so one you put under a fan and one not in another room which has no fan. So which one will evaporate first? Obviously the one which is under the fan, right? Why? Because increase in wind speed equal more evaporation. Okay, now today I've already discussed about what is evaporation and what are the evaporation based on molecular theory and factors affecting evaporation. Okay, so please go through, and I want to discuss one more. See, there are examples here. Okay, there are examples. I want you guys to read those examples. These things are not very hard, so you'll understand. Okay, so then we will discuss about why should we wear cotton clothes in summer. See, our body has a natural inbuilt system which keeps the body at 37 degrees Celsius. You know that, right? Our body is 37 degrees Celsius. If the temperature of the surrounding rises beyond 37 degrees Celsius, then the sweat glands in our skin pour out large amount of sweat. Simple. What happens is, see, our body is 37 degrees Celsius. However, when it is too hot, right? Suppose in outside, like in Bangalore, not in Delhi, right? Temperature rises up to 42 degrees Celsius and something, right? So when it is 42, okay, the body will secrete glands, right? It will in the form of sweat, so as to maintain this 37 degree Celsius. It will sweat it out. Okay, now the cotton clothes are very good absorbents of water. Now when the body sweats, okay, if you wear cotton clothes, it absorbs the water. They rapidly absorb the sweat from our skin. That's what I said. So the sweat that evaporates, taking a large amount of heat from our body, thereby giving a cool sensation. So this is what I explained about cooling, right? So what happens here? The body, which is hot, right? So it secretes out the sweat. The sweat here, after secretion, it gives a cooling effect to our body. After the sweat is secreted, we feel cool, right? However, the cotton clothes will absorb this sweat. Okay, all right, because you know, the cotton clothes will absorb this sweat. Okay, because cotton clothes, they have like these type of fibers that absorb more sweat from the body. Okay, so conversely, synthetics and also synthetic clothes are highly uncomfortable because they are not absorbers of sweat. As sweat from our skin does not evaporate, the body does not lose heat energy, and hence we have uncomfortable feeling. Can you underline this? As sweat from our skin does not evaporate. Okay, if we wear these synthetic clothes, we kind of trap the sweat, right? It cannot evaporate. Okay, the sweat cannot evaporate. The liquid, right? Sweat is a liquid, right? But it cannot evaporate to form vapor, right? And the sweat, the cotton clothes also cannot absorb the sweat. right? Hence, we feel uncomfortable when wearing synthetic clothes because they are not absorbers of sweat. As sweat from our skin does not evaporate and the body does not lose heat energy, we have an uncomfortable feeling. Understand? So this one is very important for exam point of view. Okay, it always comes. I see. Okay, so we have come to the end of this chapter, right? Chapter 1. Okay, we have come to the end. I want you guys to solve that question and I will try to give you the answers to all the exercises. Okay, exercise 1A to A, B, C, D. Exercise 1A I already gave. So B, C, D I will try to give. Alright. I will search for answers. I will give you next class. Okay, thank you.